In this problem, what we've got is a fair three-sided die that's got numbers 1, 2, and 3, and then another five-sided die that's also fair with 1, 1, 2, 2, and 3. We got a game going on where they keep score, and basically the bigger number is the score, and if they're both the same, then we keep that number. So we've got to figure out all the different possible scores and their probabilities. I see that part A talks about just the probability of x equaling 3, but I see part B needs all the probabilities. So I'm going to go ahead and do that. Many of you use a probability tree, but what you did for your second toss, you put 5 branches on there, and what I want you to see by doing this is really it's just a question of what number I got, a 1, 2, or a 3, and I just got to put the probabilities on there. You could have made your tree a little bit less gangly, though I will tell you that most people that did trees did come up with the right probabilities and figure it out right. So now what I'm going to do is I'm going to put the scores over here, the biggest number or the same number, and then the associated probability. And see, to answer part A, all I've got to do is find the number of times that it equals 3 and then add those up, and it should come up to be 7/15, which it does. Now, this isn't the way I would have done it. I would have made a possibilities table just by placing the score in the middle. So that's the larger number, and then if it's the same, the same number. And see here, you can see very quickly that there are 7 out of 15 threes. And when I go to make my probability table in the next part, well, I can easily see that there are 2 out of 15 ones, and that there are 6 out of 15 twos. And so it just makes it much easier to go ahead and set up my probability table. I already have the 7/15. I can put in my 2/15 when the x equals 1. And then I just got to put in my 6/15 when x equals 2, and I just quickly double check to make sure that those probabilities add up to 1, and they do. Now to find the expected value, I just multiply the x's times the probabilities and add them all up. This is a pretty simple set of fractions and numbers. And what I would say is that many of you changed your answer into a decimal. It's a fraction, 7/3. Leave it like that. Why mess around? Now, the variance, well, that's just going to be the number squared times the probability minus the expected value. And you'll notice I take my calculator and I just go back and change these values to their squares and then put minus the expected value squared. And I got my answer of 22/45. Now, some of you forgot to do minus the expected value squared, which kind of messed you up. Here's the rubric. You can see for part A, all they needed to see was some kind of method. You could have used a tree or the possibilities diagram. And let's see, you can see also that for the power distribution table, it really had to be there. If you had it set up correctly, that's worth a point. If you got probability 1 or 2, then that was worth a point. And if you got the whole thing, then that was worth 3 altogether. And then the last part, you can see the equations, and it's pretty simple. It's pretty basic, straightforward. So that's how we got that one. Let's go on to the next one. Question we've got. On a given day, the probability that President Trump tweets is 0.72. Find the probability that in a random sample of 12 days, President Trump tweets no more than 9 days. So, the big question here is a binomial or geometric. The fact that we have to look at 12 days and find out whether or not more of them are 9 was it. Our trials is obviously 12. This is a binomial distribution. A probability of success is 0.72, and we want to find the probability that x is less than or equal to 9. Now, that involves finding 0, 1, 2, 3, 4, 5, 6, 7, or 9, or it involves doing 1 minus the probability that x is equal to 10, 11, or 12, which I would have suggested. Then all I've got to do is write out what I'm going to do for each one of these. I got probability, and I go across here to set it up really quickly. I put in my probabilities, my exponents, and then I go to my calculator, and I just go to menu 7. I'm going to use list. I put in 10, 11, and 12. I put in that there's 12 trials. The probability is 0.72. And there are my individual probabilities, and I'm just going to write them down. I've disadvantage because every time I go to write, the calculator disappears. So I got to double check and make sure that I got this right. So let's see here. Yeah, okay, all right. So now what I'm going to do is I'm going to add these. Whoop, I messed up this one. Now let's fix this. All right, so now what I'm going to do is take these and add them up and subtract them for 1. And you'll notice I didn't write all 9 digits, but I did write 5. Some of you only put down 3 digits. That's rounding in the middle of the problem, and that's going to cause you error and not get the correct answer. Anyway, 1 minus this is going to be 0.69630. It's going to round to 3 figures of 0.696. All right, so that's part A. In part B, we switch gears. It says that President Trump tweets on November the 1st. Find the probability that the next day on which he tweets is November the 1st. So again, it's not asking how many times, the probability of a number of times. It's asking for the next time, or if you will, the first time. So what I'm going to do is kind of map this out. On the 1st, he gives a tweet. And then on the 2nd, the 3rd, the 4th, and the 5th, well, on the 2nd, there was no tweet. We'll say NT and then there. All right, but on the 5th, there was. Now, the probability of him tweeting on the 1st, that's 1, because we definitely did it. Many of you gave him a probability of 0.72. No, he actually did it on that day. So this is going to be 0.28 to the 3rd power times 0.72. And see, then all we got to do is type that in the calculator and find out what our answer is. And that's going to be 0.01580,544. Which we're going to round to 0.01580. Mind you, the first 0 is not significant, so you need to go this far out. And there's the rubric. And you can see that's pretty much what they need to see is a setup as far as the combinations and the probabilities. You can get some of you got the wrong probability, and because you didn't write down the individual x equal, 11 equal, and 12 equal numbers, I couldn't give you a point for that. So you can see this is basically what we need to see to get the points. And that's it for this one. Let's go on to the next. For question number 3, we've got a pair of fair coins thrown repeatedly until we get a pair of tails. So this could be us throwing 1 coin twice or 2 coins. We need to get 2 tails. Now, there's no specific number of trials. This is geometric. We're looking for the first time that we get a pair of tails. Where a lot of you went wrong was you said the probability of getting a pair of tails is 1/2. You know what? The probability of getting 1 tail is 1/2. Probability of getting 2 tails is going to be 1/2 times 1/2, or 1/4. Finding expected value is just the reciprocal of 1/4, or 4. If I want to find the probability that x equals 3, that means that my first success was on the 3rd trial, which means I had 2 failures and then a success. So that's 3/4 squared times 1/4, or 9/64. And then they want to know the probability that x is less than 6 before the 6th one. Well, we're going to rewrite that as less than or equal to the 5th, so we can use that formula. 1 minus the probability of failure to the 5th power, and that's going to give me the answer of 0.626 or 0.763 to the 3 significant figures. And then if we look at the rubric, well, you can see it's pretty straightforward. There's not much playing around. In part C, I could give you a point if you use the right method and your probability, but a lot of it is either you get it right or you get it wrong. Let's go on to the next one. In question number 4, we've got a very similar problem to the other one we did. We've got a certain number of trials, 10 students. We've got a probability of 0.42. We want to find the probability that x is less than 8. The ideal way to do this would do 1 minus the probability that x was greater than or equal to 8. So I'm going to go ahead and do that. Again, I write down my stuff, and all I'm going to do is fill in my exponents after I do this. And then I go to my calculator, and I'm going to find the numbers, and I'm going to add them up and then subtract them from 1. And again, I'm going to put in 8, 9, and 10. And the probability or the number of trials is 10, the probability of success. And I've got to copy these down. Some of you had a little trouble with these scientific notation. If it's 10 to the -4, then put down 3 zeros and then write the number that you see. Anyway, I get these, and then I'm going to go ahead and add them up. And then I just got to take that total and subtract that from 1. So 1 minus the answer is going to give me, whoops, I put this number down wrong. Let's fix that. 1 minus the answer is going to give me 0.9828 or 0.983. Now, in part 2, that's a different kind of question. It's the one we talked about where you've got to find the number of trials. And so basically, if it's probability greater than or equal to 1, well, that's the same thing as 1 minus probability that x is equal to 0. And so then what I'm going to do is get this by itself by subtracting 1 and then dividing both sides by negative. And see, then when I find the probability of x equals 0, well, let's n choose 0. Probability of success, well, I know what that is. That's going to be 0.42 to the 0, 0.58 to the n. Is less than 0.005. And see, then all I'm going to do is write this as a logarithm and then put it in my calculator, base 0.58, find out 0.005, and then I know that my number of trials is going to be equal to 10. And then if you take a look at the rubric, you can see, again, it's pretty straightforward. On their rubric, you'll see that they use, what happens is there's another method of doing the log base 10 of both sides. If we didn't have this calculator function, then that's what we would have to do. But it's much easier to do what we're doing, and as long as we've got this written down, then you can see you can get a point. You can get a point for trying to use a log, and then trying to write up an equation and setting it up. So that's how we go for that one. All right, I hope this helped. Thanks for watching.